Good morning, everyone. This is my fourth lecturate, and in this particular topic, I would be talking about some like two of the important concepts of theory of relativity. One of which is the time dilation, and another one is the length contraction. As the name itself suggests, time dilation means that the time will going to dilate or it will going to slow down with respect to somebody. I'm saying with respect to somebody because in relativity, something which is happening with respect to somebody is not the same which is happening with respect to somebody, provided that both of them are in the different frame of references. That's why whenever we talk about all these concepts of time dilation and length contraction, we always say these relative terms. The second concept is of length contraction, and the name here also suggests length contraction means that the length will contract with respect to somebody, and with respect to somebody else it would remain the same. Now the problem with all these things is that it is very difficult to look for these things and to observe it in our day-to-day life, because one of the basic requirement for time dilation and length contraction is that these effects are only observable when the frame of reference in which we are is accelerating at least with the speed which is very much near to the speed of light. If not near, then at least you student must be doing something like 50% of the speed of light. Then only it is possible. And this is not really like we say that if that would have been possible, if everything would have been speeding up like running at the speed of light, then its length will contract to a zero value and completely becoming vanishing at a particular point, and the time will going to particularly stop for it, because you dilate the time means you are what you are doing is that you are slowing it, right? So if you are slowing it and more slowing it, at a particular point you will slow it to such a value that it will particularly stop for you. So whenever we talk about something that is accelerating with the speed of light, then time particularly stops for it and length of things contracts for it to a zero value. So this is a very much interesting thing, and yesterday only I was seeing a video on YouTube and which was saying that it is possible for us whenever we talk about time dilation and length contraction. Let me tell you about the formula first. Length contraction is L equals to L naught upon under bracket 1 minus B square over C square, and time dilation is also having the same formula, T equals to T naught upon under bracket 1 minus V square over C square. Now the thing is, I have explained the concept. Now the next topic that I really want to jump upon is is it really possible to do the time travel? There is one scientist, I must mention, is a great he's a great fan of Richard Feynman, one of the greatest scientists. So what he mentions is that time travel is a thing that we everyday do. Actually, when we are traveling, what we say, we do change our coordinates, right? I'm not talking about time traveling particularly, I'm just talking about particularly traveling. When we say, usually when we say that we are traveling, what we actually do, we do travel, right? So we change our coordinates with respect to a frame of reference. That is what is called a traveling. So if we are at a particular point, suppose the x coordinate is x naught, and after time t we are at another point which is whose coordinate is simply x. So we have traveled a particular distance. This is what is called traveling, change of coordinate. In time travel as well, what we are supposed to do, we are supposed to change the coordinate of time, and that what we always do. Time never stops, right? So right now, if t time is t, then after a while it will going to be t plus t naught, where t naught is some value, or say t plus delta t naught, where delta t naught is a small change in time. So every time there is a change in time, so we are traveling in time. Time never stops. So what we all are doing right now is also time traveling. So what is the problem, like why we are so much curious about time travel if we all are doing in the same sense we are traveling the distance? Look, the problem with time travel is that it is only unidirectional possible. For example, if we are doing just a simple traveling, then we can go in positive x direction. At the same time, we can also come in the negative x direction. But whenever we talk about time traveling, then there is certain limitation that we can only go into the future, we cannot really come into the past. Whatever time has left the place, we cannot really go back in it. So that is the problem with the time traveler. We are three-dimensional beings, right? We have very much control in these three dimensions. We can go up, at the same time we can come down, we can go right, we can come left, we can change our coordinates, plus minus, all these things are possible. We can start it from a particular point, go in the positive direction, and the point that we have started from, we can come back to that particular point as well. So going in the future and coming with respect to the position is very much possible. But when we talk about with respect to time, once we have passed a particular time frame, then we are not able to come to that particular time. That is what is the problem with the time. This is first thing. Then the second thing is, when one more thing that I really want to tell is that whenever we talk about relativity, there is some more concepts that are very much interesting to understand. I have already mentioned that whenever something is moving, then what happens is that the time ticks slower for that particular being, right? So given that particular thing, which it means that if I am sitting here and somebody is walking behind me, then the time will going to pass slow for him, right? So what will happen is that, suppose somebody is traveling 99.9999% at the speed of light. So what will happen is that, and the time will slow so much for him that suppose a million year is passed here for with respect to me, but for him it might be only 5 minutes. So if he would going to come from that particular frame where he is traveling at the speed of light into our frame, then what he will found is that he has came 5 millions ahead, but according to him he has only traveled 5 minutes. So sometimes the physicists also talk about, whenever they talk about time travel, they give this particular example that in the future direction, the time travel is even possible to this extent as well. We can go millions of years ahead. But the problem here is that once you have got 5 million years ahead, you accelerated with the speed of light, the time particularly stopped for you, you went at 5 million years ago. But the problem with it is that once you have went 5 million years ahead, there is no way, there is no way of going back. No matter what you do, there is no going back in the time frame. So the thing is, if even if you do the time travel, suppose I am somebody who basically went in a spaceship, I sat over there, I accelerated with the speed of light, and then I went 5 million years ago. The problem with that particular thing is that it is forbidden to come back to my people and tell them that I have actually time travel, because the very much limitations is that it is only possible to change our coordinates in the frame of reference of time in only unidirectional. So that is a very much thing. So the thing is, we all are time traveling, and the thing is, the time that we are having is very much related to us only. We all are having, suppose I'm having a watch in my hand, somebody else is having watch in his hand, we all are having our own time. Why? Because if suppose I am walking at a different speed than somebody else, then for me the way in which time will dilate is very much different for which somebody else will do. But the problem why we don't really observe this thing in our day-to-day life is that because the speed with which we travel is very much insignificant in comparison with the speed of light, that all these effects become very minute and hardly observable. So we all are time traveling. If I'm sitting here and somebody is walking around me and he's doing continuously motion, then he has time traveled with respect to me as well. So this is a very much very much thing that happens all the times, but is very much hard to observe, because in order to make it very much become observable, the basic criteria is that something student must be approaching the speed of light, which is not possible. Now when I was looking at the video of Brian Cox Brian, so what he mentioned was that there is a electron collider accelerator, the proton accelerator or something he meant. He said at the sun is a place. So what happens is that there is a proton which have been accelerated. The circumference of that particular, there is an arrangement, a circular arrangement in which an electron goes around it, right? So the thing is, the proton goes around it. So the thing is, the velocity with which it is going, it is 99.9999%, the velocity, 99.99999% the velocity of light. So the problem, not the problem, the fact here is that if something is going to with that much particular speed, so the length contracts for that thing with a factor of about 7,000. So a total circumference of something around 27 kilometers is reduced to few meters only for that thing. So it is also very much interesting thing. I think it was something around 4 meters. So time contraction and time time dilation and length contraction are some of the very much interesting things, but very impossible to, I must mention, observe in day-to-day life. Thank you.